What's going on, smart people? Bringing you another coding video today. And today I'm going to show you how to do something that's very easy to do, but can really help increase the readability of any code that you write in Python. Assuming that you're doing a whole bunch of things like function definitions throughout your code, and then maybe just trying to output a couple of things at the end. So I'm going to be doing all my stuff in Jupyter Notebook, personal preference, but you can do this anywhere. But what's the first thing you do whenever you start writing a code in Python? You import the necessary libraries, right? This is where you do the import numpy as np, and that gives you access to all of the functions that numpy has. That way you don't have to write them for yourself. But you can write these modules for yourself too and access those functions from within a file. So today what we're going to do is we're going to write a code that asks for a couple numbers. We're going to define some function that adds those numbers together, multiplies those numbers together, creates a vector out of those numbers, and then does a dot product between those vectors. And then what we're going to do is we're going to modularize our code, meaning we're going to take those functions, store them in a different file. That way it reduces the clutter of our main code, but so that we can still access those functions from within our code. So let's get started. First thing that we do is we're going to define the variables that we're going to input. So x is equal to some integer input. Enter a value for x. And we can do the same thing for some y value. Okay, enter a value for y. Now let's go ahead, since we already have numpy imported, we might as well just create a numpy array for our vectors. So we can call vec1 equal to np.array x comma y. And then for our second vector, let's be a little bit lazy and just do the exact same thing, but tack on some negative signs. Now let's get into the meat of this. Let's define some functions to do some stuff. So it might be a little bit overkill to create a function to add numbers together, but just humor me here. So let's define a function add that takes two parameters a and b and returns, plot twist, their sum. And then define another function mult, takes two other numbers a and b, or they can be the same number, it doesn't matter, it just depends on what you pass to it. Return a times b. And our last function will be some dot product of a comma b. Return a0 times b0 plus a1 times b1. Right, that's just the definition of the dot product. Don't let the fact that I'm using a and b throughout this entire thing trick you. These are local variables, which means that this dot product has no idea what's going on inside this function because we're not calling it inside. So though this is going to take in numbers and this is going to take in two arrays, you know, there's no communicate. These aren't the same a's and b's. But anyways, this is the part that's also going to be changing once we get to the modularization part. But now let's feed in some values here. So let's call answer1 equal to add evaluated at x and y. Answer2 can equal multiplication evaluated at x and y. And answer3 can be the dot product between vector 1 and vector 2. And let's print what these are. Print answer, whoops. Print answer 3. Cool, so I wrote that a little bit fast, might be a typo, but let's hope not. Let's just run this. It should ask us for two numbers, x and y, and then output the rest. What is the value for x? Let's make it 2. Value for y, let's make it 3. And then it gives us their sum, which is 5, their product, which is 6, and their dot product, which is 13. So why is it 13? Oh, because I named vector 1. Pause. Back up at the top, I defined vector 1 and vector 1. This is vector 2. Why didn't you guys say something? So if we run this again, 2, 3, now we get that minus 13. Perfect. Okay. Now, what I want to do, pretend this code was so much longer. We had so many function definitions, so much more than 3. What I want to do is I want to take these and store these function definitions somewhere else. Control C, we're copying them, and then we're getting them on up out of here. Okay? Alright, so they're no longer in this code. Then we're going over to the home page, and we're creating a new file. New Python notebook. Let's create a little comment that says that this is our math file, and we're just pasting these function definitions. Great. Now we're going to go back up to File. We're going to rename this. This is going to be called, this is going to be the name of our module that we're going to be importing. So let's name this my math, something that I know doesn't already exist. Okay, so rename that. Now, there is a way, first off, whenever you save a file in Jupyter Notebook, it's going to save it as a ipynb. We don't want that. We want to download this as a .py. You can modularize the stuff in this kind of file notebook setting. It's a little bit more complicated. I'll leave a link in the description if you want to use it that way, but I always find it easier to just download it as a .py, and then we'll upload it to Jupyter Notebook. So we're going to download this. Okay, so keep, that's fine. And then in our downloads, we're now going to have a My Math notebook. Okay, so let's get rid of here, and then we're going to go down to, we don't need this anymore. Down here we have this mymath.ipy. We don't need that. Okay, so let's go up, we'll delete that, and then we're just going to refresh our Jupyter Notebook, so it shouldn't be there anymore. Cool. Now what we're going to do is we're going to go up to upload. And the reason that we're doing this is just so that, downloads, my math. Okay. We're going to upload this. The reason that we're doing this is because we want our modules to be in the same directory that we're working with. Okay, so now we have this mymath.py, and now we can access it. So now at the top here, where we have import numpy as np, we're also going to import my_math. Okay, and then instead of just having these add, mult, and dot functions that we're not actually defining in here, we're going to need to use the member access thing, right? We're going to have to do my_math.add, because we're using the mymath module that we just created, and we're using the add function from within it. Then the same thing goes here. We're going to do my_math.mult and my_math.dot. Okay, and just for clarity, you probably saw that down in my downloads I have mymath_1 and mymath_.py, the second one. Those are the exact same file. I accidentally just downloaded them twice, so just pick the first one of whatever you do. And let's run this. So let's do the same thing, 2 and 3, and we get the exact same answer, which we should, right? We're using the exact same functions. But this just makes it so that our code can be much simpler, much shorter, and if we're trying to share this with someone else, there's no need to show these cluttery function definitions if the person already knows what they are, right? The point isn't to show how good you are at defining functions. It's to show, by the way, I have another library that adds numbers together, and then they'll be able to, they'll understand that, right? This just makes it much easier to read. This was a very simple example, but I hope you see how this can apply to more complicated functions that you might need to define that might clutter up your code a little bit more. Hope you guys found this helpful. Let me know in the comments section if you did, and I'll see you guys there.